Hi elves, today we're diving into the critical topic of troubleshooting GPS data offsets.
All set.
Let's explore common problems and solutions that will help you maintain accuracy in your data. Welcome to this troubleshooting guide. Different correction sources may use different datums, leading to offsets in your data. If you're using RTK corrections or receiving data from surveyors, most likely your data is in NAD83. This leads to our first problem, defining the correct datum between NAD83 and WS84. You can think of NAD83 as the survey datum for North America and WS84 being used for everything else. If you see a 3 to 6 foot or 1 to 2 meter difference between 2 points that should overlap, this is most likely the culprit. You can use software such as Esri Field Maps to convert between different datums as you're creating data features, or ArcGIS Pro to correct points after the fact. Avoid being shipwrecked onto Null Island. There are thousands of Null Islands for thousands of different projections, but it can be generalized as the origin of any coordinate system, or 0, 0. The most common occurrence is that your feature will appear off the coast of Africa, as that is where both latitude and longitude are equal to 0. However, it can occur anywhere, such as for Arizona State Plain, Null Island is located off the coast of Mexico. How to fix this? Simply redefine your feature layer's projection to eliminate Null Island errors. U.S. survey feet has been used by American land surveyors since the 19th century. To convert to meters, they used a fraction, 1200 over 3937. However, this became wildly impractical once computers became ubiquitous, so as of 2024, all states have switched to international feet for their standard state plane projections. An international foot is a U.S. survey foot rounded to the 4th decimal place, 0.3048. So you may think the difference between the two would not be very significant. However, over millions and millions of feet, the error can really add up and amount to more than 5 feet or more. The actual error varies proportionally with the distance from the state plane origin, otherwise known as the aforementioned Null Island. How do we fix this? Change your projection settings to align with the appropriate unit using either ArcGIS Pro, NCAT, or your GIS program of choice. Finally, there are a couple things you can check in the field to ensure your points are being placed properly. Ensure your device is correctly connected to the external GNSS receiver of choice, hopefully a bad elf, and that your data collection app is using the right location source. Android users, please take note, a mock locator app may be necessary. The GPS built into cell phones can vary wildly in accuracy depending on hardware and conditions, so ensure the location data you're using is indeed from your bad elf. This can be accomplished by selecting your location source in your app, setting up a mock locator in Android, or simply connecting your receiver via Bluetooth on Apple iOS. For survey-grade receivers, tilt can introduce errors into your measurements. Be aware that 1 degree of tilt is equal to 3.5 centimeters of error, so you want to ensure your receiver antenna is located directly above the tip of your survey pole. When you're talking survey-grade measurements, 3.5 centimeters absolutely blows your accuracy out of the water, as you're usually looking for GPS accuracy of less than a centimeter or less than 2 centimeters in the vertical. Congratulations! You've just navigated through potential sources of GPS data offsets and their respective fixes. We haven't even touched on vertical offsets, so please stay tuned for that video. Remember to like and subscribe to catch that and support us, and remember, accuracy and best practices are key in geospatial work. Happy mapping to all you elves out there.